Have you ever looked at a legendary fighter jet like the F-15 Eagle and just wondered what makes it so incredibly tough? It's not just the armor plating or those monster engines. No. Today, we're diving deep right into the veins of this iconic aircraft to uncover the absolutely brilliant, life-saving engineering behind its hydraulic system.
So, picture this. You're in the cockpit, you take a hit, and a warning light screams at you. A hydraulic line's been severed. By all accounts, you should be losing control, maybe even ejecting. But if you're in an F-15, you fly it home. The big question is, how? That's the mystery we're cracking open right now.
Okay, so first things first, a quick refresher. Hydraulics are basically the muscles of a modern jet. They're these high-pressure fluid systems that give the pilot the superhuman strength needed to move the huge flight control surfaces. The ailerons for roll, rudders for yaw. Without them, the jet is just a very, very fast and heavy rock. For a system this critical, failure? Yeah, that's not an option.
So how did the F-15's designers make sure failure wasn't even in the vocabulary? Well, they started with this core principle, the triple redundancy doctrine. Now, this isn't just about having a simple backup plan. This is about engineering for absolute survival even when everything has gone completely wrong.
The secret, the absolute key to the Eagle's legendary toughness, it all starts with this number, 3. And I really want you to get this. The F-15 doesn't just have one hydraulic system with a spare. Oh no. It has 3 totally separate, completely independent systems all humming along in parallel to make absolutely sure the pilot never ever loses control.
And check out how brilliantly they laid this out. First up, you've got Power Control 1, or PC-1. Its job is to power the main flight controls. Simple enough. Then you have PC-2, which does, well, the exact same thing. It is a perfect mirror, a complete one-for-one backup. And then, as if that weren't enough, you've got the utility system. Now, its day job is to handle everything else. Landing gear, brakes, the whole shebang. But it's also the third line of defense, sitting there ready to jump in and power the flight controls if both PC-1 and PC-2 somehow go down. And this quote, right from the original design documents, says it all. I mean, just let that sink in for a second. The F-15 can lose 2/3 of its hydraulic muscles, and the pilot can still fly the plane and land it safely. That is an absolutely incredible statement about just how robust this system is. But look, having backups is only part of the story. What happens when a system actually gets hit in combat? Well, the F-15's hydraulics don't just, fail gracefully. They're actually smart systems designed to actively fight back against damage in real time. Because here's the big, scary problem. Even with 3 amazing systems, a single little leak from a piece of shrapnel is a catastrophic threat. If you don't do something about it, that leak could bleed an entire reservoir dry, making that whole system totally useless in just a matter of minutes. So the solution is this unbelievably clever system called Reservoir Level Sensing, or RLS. Just think of it like an automated damage control officer working at lightning speed. The second RLS senses the fluid level dropping, it instantly starts triage. First, it shuts off half the system to see if the leak stops. If it does, fantastic, the other half is saved and you're good to go. But what if the leak is in the other half? The system makes another split-second decision, shutting down the leaking section and saving the good half. It's designed to guarantee that no matter where the damage is, the pilot always keeps at least half of that system's power. It's just genius.
And believe it or not, there's another layer of smarts here. If a circuit does lose pressure, these things called switching valves kick in. But before they just blindly start using the precious utility system fluid, they first run a quick test on that damaged line. This is a brilliant check to stop them from accidentally pumping all your backup fluid right overboard through a massive hole. It's just one more way the plane gives the pilot more options when things get bad.
And right here, you can see the incredible results of all that smart engineering. You lose all electrical power? No problem, you still have full control. You lose 2 of your 3 hydraulic systems. You can still fly home controlling one wing, the stabilator, and a rudder. You lose both primary flight control systems. The utility system just says, I got this, and takes over everything. It is a true architecture of survival. Okay, so surviving battle damage is one thing, but what about problems that start on the ground? A surprising number of issues come from simple human error during maintenance. And the F-15's designers, they were obsessed with this, and they engineered a system that was, as they say, Murphy-proof by design. So here's a classic problem. You've got a simple one-way check valve, but if a tired mechanic, maybe working at 3 in the morning, accidentally installs it backward, well, that could stop fluid from getting to a critical control surface. A tiny mistake on the ground could lead to a total disaster in the air. And the F-15's solution is just chef's kiss. It's so simple.
The check valves are designed with different-sized fittings on each end. It is physically impossible to install it the wrong way. The engineering itself prevents the human error. It's literally foolproof.
Or how about this one? A mechanic pulls a hydraulic filter for a cleaning, gets distracted for a second, and then closes up the housing without putting the filter back in. Now you've got dirty, unfiltered fluid being pumped through the system, which can totally wreck the expensive pumps.
And again, the solution is just beautifully mechanical. The filter housing is designed so you physically cannot, reinstall it and seal it up unless the filter is correctly seated inside. It forces you to do the right thing every single time. No memory required. And the list of these brilliant little innovations just goes on and on. Pumps are plug-in style, so you don't even have to disconnect the lines to replace them. Each whole system has just one filter door with one common filter type. They replaced failure-prone hoses with durable coil tubes. The system even has return pressure sensing, which stops the pilot from flipping a switch that would pump fluid into a circuit that the plane already knows is leaking.
So when you put it all together, you've got the triple redundancy, the automated damage control, the Murphy-proof maintenance. You don't just get a good system. What you get is a fundamental, a giant leap forward in design philosophy.
Just as the engineers who built it said, the F-15 was a giant step ahead. And the results? They really do speak for themselves. The system is easier to maintain, it's way more reliable, and it gives the pilot a chance to survive that is just second to none. It's this beautiful combination of smart choices that creates a truly resilient machine.
And that really just leaves us with one final thought. The genius of the F-15's hydraulics isn't some single magical new technology. It's 1,000 small, smart, thoughtful decisions that all add up to create a system that is almost unbreakable. And it really makes you wonder, doesn't it? How many other life-saving designs like this are hidden in plain sight in the things we use every day, just waiting for us to notice? Thanks for joining me.